Hello, my name is August, and I will be doing a presentation on lymphatic filariasis. This is a disease caused by parasitic worms that affects millions worldwide and can lead to extreme disfiguration. Lymphatic filariasis can be caused by three different species of nematodes. These nematodes are all closely related. The species are Wucheria bancrofti, Brugia malai, and Brugia temori. The first one mentioned, Wucheria bancrofti, is responsible for a majority of infections. It's estimated to be responsible for 90% of infections worldwide. You can see the adult Wucheria bancrofti worms on the top. The smaller worm on the left is female, and the larger worm on the right is male. In order for these worms to be passed to humans, they need an intermediate host, and that intermediate host is mosquitoes. Unlike other parasitic diseases such as malaria that can only be transmitted through Anopheles mosquitoes, these worms can be transmitted by three different genera of mosquitoes. These genera are Anopheles, Culex, and Aedes, and it depends on where you are located which mosquito would be biting you. The CDC estimates 120 million people worldwide have lymphatic filariasis, and of those, 30 to 40 million face extreme disability from the disfigurement. Lymphatic filariasis affects the tropics and subtropics worldwide. Depending on location, both the mosquito vector and parasitic worm species vary. So, Wucheria bancrofti is present worldwide, whereas the two Brugia species, Brugia malai and Brugia temori, are restricted to small parts of Asia and Pacific Islands. The mosquito vector for the continent of Africa is Anopheles. In the Americas, it's the Culex mosquito, and in the Pacific and parts of Asia, it's the Aedes mosquito. You currently cannot be infected with lymphatic filariasis in the United States. The last recorded case of transmission was in the 20th century. Okay, now I will be going over the life cycle of Wucheria bancrofti. The life cycles of both Brugia species of worms is very similar. Starting at step 1, a mosquito will take a blood meal from the human, puncturing the skin, and at the same time it deposits larvae of the worm on the human skin. These larvae will climb through the puncture wound and enter the human. They then travel to the lymph nodes and lymph vessels where they will feed on lymph until they mature into adult males and females. If you look to step 3, they reproduce to create microfiliariae, which are microscopic worms. These will stay close to the person's organs during the daytime, and then at night they travel to the peripheral vascular system, so the arteries in your arms and legs where mosquitoes bite. At this point, a mosquito takes another blood meal, ingesting the microfiliariae, and the microfiliariae will travel to the mosquito's midgut to mature. They mature through 3 larvae stages, and when they get to the L3 larvae stage, they go to the mosquito's head, where when it takes a blood meal again, the larvae can be deposited on the skin. Now I'll be going over how lymphatic filariasis is diagnosed. If a patient has severe lymphedema or elephantiasis in a region that is endemic for the disease, they are assumed to have it. There are antibody tests for Wucheria bancrofti. However, the most common technique for all 3 types of worms is microscopy. You look at the blood smear under a microscope, and you're looking for the microfiliary. At the bottom of the slide, you can see the microfiliary slides of both Brugia species. The only caveat is that to do the blood smears, the blood must be drawn at night because the microfiliary are only in the peripheral bloodstream at night when the mosquitoes feed. The CDC recommendation says to draw the blood after 8 p.m. Okay, now we'll go over the clinical picture of the disease. Most people infected with the worms are asymptomatic. When damage does occur, it happens to the lymph system, since this is where the worms mature, feed, and breed. The major damage that occurs happens when the adult worms die. They can clog lymph vessels, which leads to swollen lymph nodes, lymphedema, which is collecting fluids, usually in your legs or arms, elephantiasis, which is a more severe form of lymphedema, or scrotal swelling, also known as hydrocele. All of these conditions are extremely painful and disfiguring. I'm going to give a few examples of lymphedema and elephantiasis in the next slide, so if you don't want to see pictures, please skip ahead. Okay, here are some photos from the WHO website showing patients with lymphatic filariasis. As you can see, there's an extreme amount of swelling and fluid buildup in their lower extremities. This is extremely painful and basically disables them. They're unable to work and they have a harder time moving around. But they can also be socially isolated from their community due to the disfigurement. Lymphatic filariasis is one of the neglected tropical diseases that the World Health Organization has recognized for elimination goals. In 2000, the WHO created the global program to eliminate lymphatic filariasis. The original goal was to eliminate it worldwide by 2020. However, as of October 2020, this goal was pushed back to 2030. The WHO is sponsoring mass drug administration of antiparasitic drugs to regions that are endemic with lymphatic filariasis. The drugs are diethylcarbamazine, also known as DEC, albendazole, and ivermectin. They're usually used in combination with each other depending on which other parasites are endemic to the region. These drugs prevent transmission to others. However, for those suffering from severe symptoms such as lymphedema or elephantiasis, they provide little relief. Okay, I'll now present a case study on lymphatic filariasis in the United States. So the patient was an 11-year-old female from Massachusetts who presented with a swollen lymph node for approximately a year. When the doctors removed the lymph node and cut it open, they found a Brugia worm. The patient had no history of travel to endemic areas. The family unfortunately never followed up with the doctors that published the case study, so we don't know if she ever received the CDC suggested antiparasitic drugs. What I thought was most interesting about this case study was that there have been 28 cases of Brugia worms being found in people in the United States, and these were not Brugia malayi or Brugia tumori. They were a different species where the definitive host is bobcats or rabbits. Other recent research has had the effort of mapping the transmission of lymphatic filariasis in detail. Several countries have already been successful at eliminating the disease, including Japan, China, South Korea, the Solomon Islands, Egypt, and Togo. The paper that we're looking at here compiled data from 72 countries that are endemic for the disease. Of those, 59 completed their surveys, and only one had not started their surveys. If you look at the graphs, the left picture of the Africa continent has blue dots and red dots. The blue dots show there is an absence of transmission, and the red dots show that there is transmission. And then to the right, the rainbow-colored African continent shows how sustainable the environment would be to spreading lymphatic filariasis. So areas that are red have a high environmental suitability for transmission, yellow is a medium amount, and then low is blue. So you can see how these areas overlap where lymphatic filariasis is occurring. The main point that this paper was displaying was that even though countries are endemic, where we are seeing lymphatic filariasis is not across the entire country, it's in very limited regions. The last bit of research that I wanted to end with on lymphatic filariasis is on vaccine trials. So there is currently no vaccine approved to prevent lymphatic filariasis in humans. However, there was one vaccine in animal trials, and it showed pretty good results. It had 57% protection from lymphatic filariasis in monkeys, and it showed high antibody titers and memory T cells. The researchers on this vaccine hope to eventually get it approved so it could be added as a tool for elimination efforts.